Hello, Matthews Gatos here. Welcome to section 4.4, the quadratic formula. Before we get into that, I just want to review with you completing the square with this numeric response question. So I want to find the exact value solution to x squared minus 18x plus 20. So first thing I hope you notice, this cannot be factored. So that's why we're completing the square. So to complete the square, what I'm going to do is take my first term, x squared, and I'm going to take my middle term, negative 18x, and divide it into two equal pieces. So what we want to do is find the value that will complete the square. So factor out a GCF from my first column and take out the leading coefficient to get x minus 9. Factor out the GCF of the first row and take out the leading coefficient to get x minus 9 here. So to complete the square, negative 9 times negative 9 is positive 81. So that will complete my square. So I've got x squared minus 18x plus 81 minus 81 plus 20. So the reason I add and subtract 81 is to maintain balance, because 81 take away 81 is 0. And I can add 0 to any question without changing its value. So let's focus in on the perfect square trinomial. Let's try that again. Focus on the perfect square trinomial here, which is x squared minus 18x plus 81. That factors as x minus 9 times x minus 9. So I'm ready to factor. It's going to be x minus 9 all squared, and then group my like terms on the outside. So I have negative 81 plus 20 is negative 61. So now that I've completed the square, I can solve it by setting it equal to 0. So to solve this, I'm going to solve x minus 9 squared minus 61 equals to 0. So I want to get my square term by itself, and I'll do that by adding 61 to both sides of the equation. So I'm using reverse order of operations. So I get x minus 9 squared equals positive 61. Now, to get rid of my square root, my squared term, I'm going to take the square root. So squaring and square rooting are inverse operations, so they undo each other. So these cancel, so I'm left with x minus 9 equals. Now remember, when you take the square root of a number, this was the square root principle, it is equal to positive and negative that answer. Now 61 has no perfect square factor, so that's as far as I can go. So I'll add 9 to both sides, and now my variable is isolated. Always start with your number first, so 9 plus or minus the root of 61. So I can leave my answer like that because it is a root. I just want to be really clear with you guys that you do have two solutions, or two x-intercepts. 9 plus the square root of 61 and 9 minus the square root of 61. So let's check this on the calculator. The check, again, the most important part of any solving question, because you're going to know if you did it right just by checking. Okay. So in y1, I'm going to put my equation, and then I'm going to start my table at my two different solutions. So here's my original equation, and you can see I enter in 9 plus root 61 right here. It's an irrational number, but it makes the equation equal 0. And then I enter in 9 minus root 61 right here. It also is an irrational number, and it makes the equation equal to 0. So important that you use the exact values, otherwise if you use rounded values, it won't exactly equal 0. So in this lesson here, we're going to look at the quadratic formula, what it is, how do we use it, how do we solve word problems with it. In the second part of the video, we're going to look at the discriminant and nature of the roots. So let's look at what the quadratic formula is. The quadratic formula is used to find the roots of a quadratic. It could be factorable or non-factorable. It's just a quick kind of way of figuring out what the solution is. The way that the quadratic formula was derived is it's found by completing the square of a general form quadratic. So this quadratic right here. If I complete the square and then solve it, isolating for x, I would get my quadratic formula. If you're interested in seeing the proof or how the quadratic formula is derived, I have an optional video here on my YouTube channel explaining that. So when I learned the quadratic formula, we weren't given formula sheets, we had to memorize it, and I learned it to the tune of row, row, row your boat. I'm going to spare you my singing voice, but here's how it went. It was x equals opposite b plus or minus the square root, b squared minus 4ac divided by 2a. And it was just that simple. Actually, it was so simple that a 6-year-old can remember it. So this is my little Teo in 2015. He heard me sing the quadratic formula so many times, he actually started singing it himself. So he threw on a big math at the end because he was so proud that he had it memorized. So easy, a 6-year-old can do it. A couple of things that you might notice from the video that I wanted to clear up. These are in fact fake glasses. They're 3D glasses from the movie that he popped the lenses out because he said to do math at 6 years old, he wanted to look smarter and he thought glasses made him look smarter. And yes, you are correct. That is red SpongeBob that you see on his shirt. So let's use this easy quadratic formula to do some questions. Before we do, a couple tips for you. I want you to set the quadratic function or equation, to 0 and carefully state your a, b, and c values, paying attention to your signs. Are they positive or negative? When you substitute it into the quadratic formula, use brackets to show your substitution. And then just like completing the square, I want a simplified radical. And because it is a fraction, I want a simplified fraction. So you're going to look for factors that are common to the coefficients, not to the root. So without further ado, let's try a question. So here is my quadratic equation already set to 0. So I'm just going to do my ABCs. So A is the number in front of x squared, which is positive 3. And that goes in 2 places in the quadratic formula. B, the number in front of x, is 5, and it goes in 2 places. Remember that first part of the quadratic formula was x equals opposite b, which just means the opposite sign. And then c is your y-intercept, your lonely number of -2. So to simplify this, what I'm going to do is enter what is in this underneath the square root, without the square root itself, just what's underneath the square root into my calculator. And then I'm going to simplify. So I have x equals -5 plus or minus the root of 49 all over 2 times 3 is 6. Now, square root of 49 is 7, so I can simplify this a little further. So -5 plus or minus 7 over 6. Now, if that was a root 7, it's okay to leave your answer like that, but since it's a number, I need to work it all the way down. So x equals -5 plus 7 over 6, which is 2 over 6, or in lowest terms, 1/3. Or x can equal -5 minus 7 over 6, which is -12 over 6, in lowest terms is -2. So this quadratic has 2 possible solutions. X is 1/3 or x is -2. Let's try another one. So this one here looks a little bit different because I have fractions. I don't want to simplify fractions with roots and fractions on top of fractions. So my tip here is to get rid of your fraction first. And the way that I'm going to do that is by multiplying every term by 2. If I do it to every term, including the other side of the equation, I maintain my balance. So I have half of 2, which is just 1, so t squared, minus 2 times t minus half of 2 is 1 times 5 is 5 equal to 2 times 0 is 0. So now that I've got rid of my fractions, I'm good to substitute all my values. So looking at the number in front of x squared or t squared, it is equal to 1. And 1 goes there in 2 different places in the quadratic formula. The number in front of t is my b value, which is -2. That goes in 2 places. Remember, it is opposite b, so it's +2. And then c value of -5, the lonely number, the y-intercept goes there. So again, I am going to put what is underneath my square root sign without the square root itself into my calculator. So putting it into my calculator, I see I have the answer of 24. So I have x equals 2 plus or minus the root of 24 all over 2. So let's break down 24. I know 24 breaks down into 4 times 6. So the square root of 24 breaks down into the square root of 4 times the square root of 6, which is just 2 root 6. So let's simplify that further. So I have 2 plus or minus 2 root 6 all over 2. Now remember in the beginning I said I want us to simplify our roots, which we did, and I also want us to simplify our coefficients, not including the root. So what I'm going to do is draw a heart around my numbers because I love my numbers, but I want them to be in lowest terms. So I do that to remind myself 6, the root 6 is not part of the simplified process. So I see 2, 2, and 2, so wild guess, 2 is probably a greatest common factor, and in fact it is. So I divide 2 by 2, 2 by 2, and 2 by 2. So I end up having 1 plus or minus 1 root 6 all over 1. You can leave it like that, but I think a better way of writing it would just be 1 plus or minus root 6. And you can see there are 2 answers, 1 plus root 6, 1 minus root 6, but I can leave them combined together because it is a root. Okay, in our last question here, I would recommend pausing the video, trying this yourself, and then coming back to see if you've done it correctly. So in this question here, it's already set to 0, which is good, and I have no fractions, so I'm good to substitute everything in. So a, the number in front of my variable squared, is 5. That goes in 2 places. B, the number in front of my variable, is -4. That also goes in 2 places. Remember, the first number is opposite B, so from -4 to +4. And my C value is my y-intercept, or my lonely number. So again, just like before, I'm going to simplify what is under my root without taking the root. So I plug it in exactly as it looks, and I get -4. So let me just write this down so we can kind of see it a little bit better all together. So this is 4 plus or minus the root of -4 all over 10. And hopefully when I write it out like that, you see a problem. I am taking the square root of a negative number, which I'm not allowed to do in the real number system. So what I can say here is that there are no real roots to this equation, because I can't square root a negative number. This means there are solutions in the imaginary number system, but not the real number system. Okay, so to end this lesson, I just want to do a word problem with you. So there's a lot of these in your homework, so good to go over. So we have a mural that's being painted on the outside wall, and that outside wall measures 15 meters by 12 meters. A border of uniform width surrounds the mural. It's kind of like framing it. The mural covers 75% of the area of the wall. How wide is the border? Okay, so what I want to figure out is the dimensions of the mural here in the middle. I want to figure out the dimensions of this. So let's find the length of the mural first. So looking over here at the length. The length of the wall is 15 all the way across. So if I look at this, the length of the wall is 15 meters all the way across. If I slide this up, you can see 15 meters is not the length of the mural because it has this uniform width around it, kind of like a matting, okay, so where it's not painted. So I don't have any painting of the mural here for X or for here for X. So I'm actually going to subtract from the 15. I'm going to take away the width of X, and I'm going to take away another width of X. So really what I've done is I've taken from 15, I've taken 2 X's away. So that will become the length of my mural. Let's do the same thing for the width. So the width of the mural is 12. So looking at that, it is 12. Now, 12 is the height or the width of the wall, not the width of the mural. If you slide this up here, you can see it's not the width of the mural. So similar to the process before, 12 is all the way across, but I'm taking away a measurement of X from this side. I am also going to take away a measure of X from this side as well. So you can see here that I'm left with this piece here of 12, and I've taken away 2 pieces of X. So this width of the mural is going to be 12 minus those 2 X pieces. So we're going to put that together into a question. Okay, so putting it all together, area is length times width. Now area was 75% of the original wall. So look what I did here. 75% of 15 times 12, that's the original area, is equal to length times width. So a length of 15 minus 2x times a width of 15 minus 2x. So we're going to go ahead and figure this out, simplify it into a quadratic so that we can then use the quadratic formula to help me. So let's figure out the area. So area is 0.75, 75% of the original area. That is 135. So I know that this will equal to 135. And then let's expand and we can group like terms. Okay, so I'm going to do over here 15 multiplied by 12, which is 180. I'm going to do 15 times negative 2x, negative 30x. Negative 2x times 12, and negative 2x times negative 2x is positive 4x squared. Okay, so let's put our 4x squared first. Combine my like terms here. So I have negative 30x and negative 24x is negative 54x plus 180. So remember, we always set our equations equal to 0. So I'll subtract 135 from both sides. So I get 4x squared, and I have my minus 54x, and then 180 take away 135 is 45. So this is the formula or the equation that I'm going to solve to figure out x, which is my width of the border. Okay, so over here, I am going to use the quadratic formula to solve this. So first thing is the number in front of x squared is 4. So 4 goes in 2 different places. Then the number in front of x is your b value, which is negative 54. But remember, on the outside, it's opposite b, so it's positive 54. And then c is your y-intercept, or your lonely number of 45. So what I'm going to do is enter in what I have underneath the root without taking the root, and then write out what I have. So right now I have x equals 54 plus or minus the root of 2,196 all over 8. Now, because this is a word problem, I don't need to simplify this any further. I just actually want a decimal value. So I'm going to plug this into my calculator to figure out what that is. So you can see here I've done 54 plus the root of 2196 over 8 and 54 minus the root of 2,196 over 8. And I get 2 possible answers. So this means the width of the mat could be 12.6 approximately meters or 0.9 approximately meters. So you have to decide which one, if any, of those are a good solution. So I have a little tip for you here. And my tip is, let me just expand my page to pull it down here. You can't take 12.6 meters from each side. There's simply not enough room. Because remember, your original dimensions were I think it was 15 by 12. Let me just go back here. It was 15 by 12. So you can't take out 12.6 from both sides. There's just not enough room. So 12.6 is actually called an extraneous root, which means it's a root of the quadratic, but not a root or an answer to the problem. So what I'm going to do is I'm going to show that by saying that x cannot equal to 12.6. And that will tell me that the width of the mat, or the width of the border, maybe we'll say border, the width of the mat or the border is approximately 0.9 meters. That makes sense. The other one does not. Okay, so I hope that that question made sense. There's other ones like that in your notes, practice questions, and also in the textbook. So I want to end this lesson by asking you, what does the baby parabola drink? And hopefully you've got the answer to this. It, of course, is quadratic formula. So I have 2 practice questions in your notes, and then you can move on to textbook questions. I hope this video helped, and I look forward to seeing you for the next one.